Hi guys, Ms. O'Connell here. So based on the Google form, it seems that we have no homework questions. If you have a 0 in gradebook for any of the homework checks, please send an image to me via email of your homework so that I can give you partial credit for those missed homework checks. Okay, so if you have a 0 in there for homework check 1 or 2, that corresponds to the textbook homework. So please send me a picture of the textbook homework so I can adjust that in Gradebook. So our momentum test is going to take place in class on Monday. Okay, we've been reviewing all week. The format of the test, it has been converted to a Google form. So there will be 20 multiple choice questions. One of those will be the choose two. So there'll be 2 correct answers. You must check the boxes that apply. And the second part of the test will be open-ended. There will be multiple parts so that I can give you partial credit. One of the questions will be on the center of mass, so finding the x and or the y position for center of mass. And the second open-ended will be an impulse momentum question. Okay, so your test will take place on Monday. You must take the test during your class period. I'm going to say that again. You must take your test during the class period. Okay, so from 8:08 until 9:41, at 9:41, your test should be submitted. I will be on Google Hangout, okay, and I highly recommend that you also go onto Google Hangout so that you can ask me questions or I can clarify any directions that we seem to need help with. Okay, so you'll go on to Google Classroom, you'll open up the Google form, you'll add yourself to Google Hangout, you'll use your note card and your calculator to take this test. Again, that's Monday during your class period. The equations that you should have on your note card. Okay, and please double check right now. If you don't have a note card, take out a piece of paper and make one. Okay, so the equations that we should have. For momentum, to calculate momentum simply, P equals m times v. That next equation, delta P, change in momentum, is mass times the change in velocity. Momentum in all collisions, elastic, inelastic, explosions, momentum is always conserved. Okay, so that equation here, the first one, m1 times v1 initial plus m2 times v2 initial equals m1 times v1 final plus m2 times v2 final. That's the conservation of momentum for elastic collisions. For inelastic collisions, in which the objects stick together after the collision, we can use this equation for conservation of momentum. Okay, in which again states that the sum of the initial momentum must equal the sum of the final masses times their shared final velocity. Okay, so those are the strictly momentum equations. For momentum and impulse, okay, we know that impulse is equal to an object's change in momentum, right? A force is required to change an object's momentum. Force times time is equal to the impulse, okay, and that is equal to mass times the change in velocity. And remember that this impulse momentum theorem is derived from Newton's second law. We use those equations when the force applied during a collision or interaction is constant. If the force is not constant, we are given a force versus time graph. Given a force versus time graph, to find the impulse or the change in momentum, because they're equal to each other, we take the area underneath the force versus time graph to find the impulse. Last set of equations that we talked about was determining the center of mass of an object, which is the average location of matter for a system or particle. The center of mass, that position, either moves at a constant velocity or does not move at all. To find that position, we take the mass times the location in the x, we sum them, and we divide by the total mass of the system. To find the y coordinate, so the position of the center of mass, we sum the masses times the y position divided by the total mass. Position of center of mass is measured in meters. Okay, so that's the coordinate x sub cm, comma, y sub cm measured in meters. Impulse, remember, is measured in Newton seconds, Newton times seconds, due to its definition, force times time. Momentum is measured in kilogram meters per second, due to its definition. So although a Newton second is equal to a kilogram times meter over second, the difference has to do with which variable we are labeling. So please make sure we do not mess up our units. Okay, so that's it for today. If you have any missings for the homework checks from 2 weeks ago, please send me a picture, adjust your note card, and I will see you on Monday. If you have any questions, you can send me an email. Have a great weekend.